Accuracy comes from averages. There's a big misconception among parents when it comes to education. They focus almost entirely on distinctions at the end of metric. And logically they do, because those are the requirements set by universities. But this approach, while seemingly practical, is deeply flawed. Distinctions open the doors to university, but it's your averages that will ensure you stay there. The reason we create these videos is that most students lack the what, the why, and the how to succeed in maths. And at FPT Mathematics, we teach them the what, we explain the why, and show them how to apply it. And once they have all three, only then do they truly succeed. And we do this while saving them and you time, money, and effort. The correct way to view academic success is through the lens of averages. You probably heard a first-year university student say, "University is a whole new learning journey." They talk about how the work is far more complicated than what they did in metric. But why does this happen? It's not because university is inherently impossible, it's because students have been conditioned to cram for distinctions rather than master the subject. And so what they do is they play the game of luck. Think about how most metric students prepare for exams. They solve every past paper they can get their hands on. They attend every extra class, every tuition session, every seminar, just to secure that distinction. But in doing so, they make a fundamental mistake. Every possible question cannot be tested in a single paper. So students play a game of luck, hoping that the questions they've practiced will appear in the exam. And when they do, they feel confident. But when they don't, panic sets in. This is why so many students struggle in university. They never truly understand the work. They just memorize patterns. If you took the average of all of your maths marks from the beginning of high school, you'd likely realize something shocking. You don't understand maths as well as you think. Let's say that you've been scoring 40s and 50s throughout high school, but suddenly in metric you get an 80. Does that mean you've mastered maths? No. It likely means that your teacher gave you a simpler test, or that you've happened to practice the exact same question that appeared in your exam. And so if you take the average of all of your marks, you are not an 80% student, you are in fact a 62.5% student. And why this is so important? Because this is not enough at university. At secondary school, if you score 60%, you're likely to score 50 or 40% at university. Because if you don't understand the work well enough, then your marks are likely to drop by 10 to 20%. And so the way you find out your actual mark at secondary school is by finding the average of all of your marks. And the way you find out the marks that you're likely to achieve at university is by taking your average and subtracting 10 or 20% from it. This is why we have a university dropout crisis. So instead of focusing on the 80% towards the end of your learning journey, you need to try to be as close as possible to the 100 mark, right? Or to the 80 mark, so that your average is good enough for university. When you look at accuracy, accuracy is about how close you can get to the target point, or how close you can get to the bullseye, or how close you can get to the benchmark of 100%. And so if you look at these two diagrams, this diagram illustrates low accuracy and this illustrates high accuracy, because you're getting as close as possible to the benchmark. So it's about how many times you can get closer to the benchmark consistently. That's the important point. And so you can't look at this as a destination but a journey. So from grade 8 all the way up to grade 12, you need to consistently do well, because that's a good predictor of success at university, right? And the low accuracy results usually comes from luck. When you try to solve as many questions as you can, trying to do as much as you possibly can. So you're putting in the work. It's hard work, but not smart work. And so that doesn't take you too far. And so you may have a few results that will be close to the bullseye. And it may happen at times that you've put in extra work, but without intentional planning, you will never do so consistently. And so you need to try to be as close as possible to the benchmark. And that only comes with intentional planning. So what do you actually need to do? You need to prioritize understanding over memorization. When you start to memorize work, you may have a complete building, but you have cracks in the foundation. And so that's not a sustainable approach when it comes to learning. You need to ensure from the ground up everything is built completely and as strong as possible. So you have a strong foundation. And so if we wish to create a, let's say, a 3-story building, we have a foundation that can hold us and take us that high. Right, so what's the solution? You need to master maths at each level, not just in metric, not just when exams are on the corner, but every single time you write a test. For every paper, you must try your best, not just to get a good mark, but to understand the work. This approach requires effort. It's harder at the beginning, but once you commit to it, something incredible happens. You stop relying on luck, you stop fearing difficult questions, and you develop true mathematical intuition. And when you get to university, it will just be the next level of something that you've already mastered. Here's my final thoughts for both parents and students. Distinctions should be the result of deep understanding and not the end goal. Shift your focus from marks to mastery. Mastery ensures success beyond secondary school. And so these two diagrams here give a nice illustration of exactly what we were trying to prove throughout this video. A student whose marks swing unpredictably throughout the year is in a far worse position than a student who maintains a consistent average. So even though this student may have had more distinctions in secondary school compared to this student, but his average, on average, the student is better. Because you can see that this is a 67.5% student versus a 62.5% student. And so it's better to be consistently good than unpredictably good. Right? So you need to know exactly what you're doing, why you're doing it, and how you're doing it. That's how you become, on average, better. Right? And so the reason I stress this point so much is because there could be questions at grade 8 and grade 9 that you will work with that you'll never understand. And then at grade 10, 11, and 12, those topics may not be examinable. As a consequence, you would deem those topics insignificant. You think they're not important, so you would think that you are ready for your university years. When you get into university, those topics are then talked about. And so if you look at it from this perspective, at grade 8, you're basically trying to strengthen your mental maths. You're trying to get good at working with numbers without the use of a calculator. At grade 10, we introduced the calculator, so students become over-reliant on calculators. When you get to university, certain courses like engineering and accounting, you're not allowed to use a calculator. And so that years that you were robbed of understanding maths thoroughly now becomes important. But the time is already up. You're already in university and you need to make up for all of the time that you lost. And so this is why it's so important that you ensure from the start of secondary school right to the end, you maintain that average and you maintain that performance. Your marks cannot swing unpredictably because then you're going to have a problem when you get to university. So let this guide your thoughts and help you make much more informed decisions when you're studying. Right? So always keep these things at the back of your mind because these things really matter at the end. And we're not talking about success just limited to secondary school because everyone is hyped up about distinctions at metric. But when you get to university, you never hear of those students. It's for this exact reason.